In this session, we are going to discuss on the prime number program. So let's see what is a prime number. Prime number is something which is divisible by 1 and itself. So examples are 3, 5, 7, 11. So if you take any number, let's say take 7. 7 is divisible by 1 and 7. It is not divisible by any other number apart from 1 and 7. What about 9? 9 is divisible by 3. So it is not a prime number. So we know what is a prime number. So now we need to we need to develop a Java program which tells us whatever number you are giving is a prime number or not. So your input will be a number, and then the output will be, it is going to say whether it is a prime number or not a prime number. So before we start writing the code for any problem, we need to first understand the problem. What is exactly the problem, and then we need to basically try to see how we will be doing that in a manual way. So in this case, how we are going to do or determine a given number is a prime number. So we'll take one example, say 119 as an example. So if at all it is, no, don't worry about any programming now, just think about logically how you will be approaching this problem. So how you will be deciding whether 119 is a prime number or not. If you are given a paper and a pen, how you will be working out and deciding, or how you will be confirming whether 119 is a prime number or not. Okay, so by definition, what we said, prime number is a number which is divisible by 1 and itself. So here 119 should be divisible by 1 and 119. That means 119 should not be divisible by any other number starting from 2 to 118. So what we are going to do in a manual way is, we are going to divide 119 by 2 and see whether there is any remainder, and that remainder should be 0. That means when you do 119 percentage 2, it should result in a value 0. But if you divide by 2, it is not going to it is going to have a remainder here, so it is not divisible by 2. And then we are trying to divide it by 3, it is also not divisible. Divided by 4, of course it is not divisible because it is not divisible by 2 itself. So you are going to divide it by 5, again it is not divisible. You try to divide it by 6, it's not divisible. When you divide it by 7, it is divisible, it is going 17 times. So now we found out 119 is not a prime number because it is not only divisible by 1 and 119, it is also divisible by another number which is 7. Now, do we need to continue and see 119 divided by 8, 9, 10, 11 like that till 118? We don't need to, right? We can stop here, because what is the rule for prime number is, if it is divisible by any other number other than 1 and 119, then it is not a prime number. So we proved that, we assumed that 119 is going to be a prime number, and we started trying to divide them. But what we proved here is 119 is not a prime number, and when we proved it, when we divided by 7, we proved that it is not going to be a prime number. So the moment I decide 119 is not a prime number, I don't need to continue this. I can just report to the user that 119 is not a prime number. Let's see how we can do this in a Java program. So we have the main method, and let's take the same number 119, and we have variable called num which is storing this value. Now we assume 119 to be a prime number, so I am saying boolean prime is equal to true. So I am assuming this to be a prime number. Now I am going to divide 119 by 2, right? So how will you write in the Java code? If num percentage 2 equal to 0. What do you mean by this? 119 percentage 2 means divide 119 by 2, and it is going to give you the remainder here, and you are going to compare that remainder is a 0 value. So that's what you are comparing, equal to 0 here. And once you compare it, if it is equal to 0, it indicates that it is divisible by that number. So in this case, it is divisible by 2. But 119 divided by 2 is going to give you 1, which is not equal to 0. So this if part will not be executed. Then what you're going to do, you're going to again write a code for dividing it by 3. And it's not going to be divisible by 3 as well, and 4 as well, 5 as well, 6, and when you divide it by 7, you're going to get the remainder as 0, and that is, the if part is going to give you a true value here. Then it is going to go inside the loop, inside the if block basically. So what is going to happen here is we assume prime is equal to true before we entered this if, but I have to change my assumption where this now the prime number, it is no more a prime number and it is going to be becoming false here. So I cannot write a program starting from num percentage 1, num percentage 2, 3, 4, 5, 6 like this actually. At least I know for 119 I need to do till 7. But what I would not be knowing for another number actually, right? If I give you 275 or 79, I don't know really. Um, I cannot do it, like writing a program like 279 divide by 2, divide by 3, divide by 4 like that. So here comes our rescue, we have our for loop or, while loop, which is going to, repeat the operation, whatever we are performing. If you want to repeat it, you have that way to repeat it with the help of our looping constructs. So here I'm going to use a for loop, and instead of, the number 2, 3, 4, 5, 6, I'm going to replace it by I. Now what is the range of I wanted to give? I wanted to, in this case, it is going to, the range is going to be from 2 to 118. If the number is going to be 279, then the range has to be 2 to 278. If the number is going to be, what I'm going to check is 11, then the range should be 2 to 10. So it is basically 2 to number minus 1 actually, right? So what I'm going to put here is, I'm going to put a for loop where I is going to start from 2, and I is going to go till I is less than the number. When I say I less than the number, in this case, I less than 119, which is I is going to start from 2 to 118. So what this if part is going to do now is, for every I, it is going to divide the 119 with that I value. So first it is going to divide by 2, second 3, 4, 5, 6, like that it is going to divide till 118. But if you remember, based on our algorithm or the manual process, what we did is, if at all at some point of time, if I identify that it is a prime number, I don't need to continue dividing this and proving, right? Because I already identified it is not a prime number. If it is going to be a prime number, then I have to go till the end. But if it is not a prime number, I can just quit. I don't need to really go till the end, right? So we have our break statement, which is the branching statement, where I can use that. If at all you identify a number is a prime number, if it's not a prime number, then you can break the loop. When you say break, it is going to break out of the immediate for loop that it is present in. So now what is going to happen, your program execution is going to come out of the loop, and it is going to come to the line that is next to the for loop. So now here you are going to print system.out.println. Prime is the variable. Now it is going to be either true or false depending on what number you are supplying in the input. If you have given 7, then it would have remained as true. You would not negate your assumption. But since it is here in this case 119 is not a prime number, it is going to, the prime will be false, the boolean value of prime will be false, and it is going to the else part of the ternary operator. So it is going to print not a prime number. Okay, let's try to write this as a method. Okay, so and we'll see how to what benefit we get by writing it as a method. Okay, so this is our program in the what we have discussed. Now I wanted to write it as a method. So when you want to write it as a method, I just need to move the logic to the method. So if you see, I have created a method, so this logic is the one which is going to move to that method. Here, as you see, the method name is prime is the method name, and it is going to return a boolean value, which is going to be true or false, and it is going to accept a number. So this method signature is, you are basically giving an integer argument, and then you are expecting a boolean in return. Here by contract it says I'm going to call is prime method, and when I call the method I'm going to give a number to it. In the method, I don't know what it is going to do, how it is going to do. All that I'm expecting from the method is to say me whether the given number is a prime number or not. So that is exactly what we're doing here. So as you see here, the logic whatever we have written starting from boolean prime is equal to true till the end of the for loop, it is the same. Okay, but the only difference is I am returning the prime value. Instead of printing whether it is a prime number or not, I am returning the prime value here, whether it is true or false. Okay, so in this case it is going to return false because 119 is not a prime number. And once I get the value as false, so how do you call this function? Basically you have moved this part of code to this function, but how we are going to invoke this function is by calling with the method name. So you're going to say is prime of number is 119, so it is going to pass is prime of 119 and it is going to get back true or false. In this case it is going to get false, and you are going to store in main method the variable prime is equal to false here. And after that you are going to execute the system.out.println, which says for if it is false it is going to print a not a prime number. So all that we have done is just move the logic to a method and call that method. So we'll see how it is going to be giving us benefit. So by this way of moving this to a different method, I can simply use is prime of 7. If you see in the next system.out.println, so if I want to check whether a 7 is a prime number, I just need to call the method is prime of 7, which is going to return me a boolean value true or false, and based on the true or false value it is going to print whether it is a prime number or not a prime number. So I don't need to repeat the whole logic again for 7. Whatever I did for 118, I don't need to repeat myself. So like this I can call the same method with different numbers and I can get the result actually. So let's see how this method can also be reused. Suppose if I wanted to print only the prime numbers here. I don't want to print the non-prime numbers. I don't want to say whether a given number is a prime number or not. Instead, I want to generate the prime numbers. Generating in the sense, if I say, hey, can you give me the prime numbers starting from 1 to 100, right? So I will be printing only the prime numbers. So let's see how we do this. So we have already written the method. So here is our prime method, is prime method. So this prime method is going to accept an argument and is going to return true or false for this. Now in our main method we are going to call this. So how do we call this? Let's say I have n is equal to 100 and I'm going to call if is prime of n. That means if is prime of n is going to be true, then I'm going to print that. If it is false, I'm not going to do anything here. So that is the program what it is going to do. So in this case what is going to happen is it is going to pass is prime of 100 and is prime of 100 is going to return false because it is not a prime number, and I'm not going to do anything in this program because it is not going to execute system.out.println. Okay, now instead of checking it for 100, I wanted to check this for a range of values. For example, I wanted to compare starting from 2 I want to check whether 2 is a prime number, and if it is a prime number I need to print it. I want to check 3 is a prime number. If it is a prime number I need to print it. Like this I need to go till 100. So how do we do this? Instead of having n as a single value, we wanted to replace that with a loop of value. So I'll just put a for loop here. Instead of having n as a variable, I'm going to have in a range of values. So first n will be 2. So it is going to check for 2 is a prime number or not. Then it is going to check 3 is a prime number or not. 4 is a prime number or not. Till n becomes 100, it is going to repeat this prime number checks 100 times. And whenever it is returning true, the function is returning true, it is going to print the number. Otherwise it is not going to print the number. Let's do this in Eclipse, the same program. Create a class and I'm going to say prime number test, having this public static void main. Let's say finish. So this prime number, testing the prime numbers. So I'm going to write it as a method as we discussed before. So I'm going to write a method public static and it is going to return a boolean. So I'm going to say is prime and then say integer number. What I'm going to do is I receive the number from somewhere, so I'm going to work with the number and I'm going to return whether it is a prime or not. So I'm going to assume whatever number I'm getting is a prime number. So I'm going to put boolean prime is equal to true here, and I will negate the assumption if I'm able to, if it is divisible basically. So I'm going to start my loop for int I is equal to starting from 2 I less than the number I plus plus. Then I'm going to check for if the number whatever I passed percentage I, which is going to be in the range of 2 to that number minus 1 equal to 0. Then I'm going to negate my assumption where I assumed this as a prime number. Now it is no more a prime number, so I'm going to make it as false and then break this loop. So if at all this condition is hit, it is going to come out of this particular for loop, and once it comes out of the for loop, whatever the prime number, whatever the prime variable is holding, that is returned. So in case of, let's say in case of 5, prime will be assumed as true, prime, and then it is going to repeat for 5 divided by 2, which is going to give a remainder, 5 divided by 3, which is going to give a remainder, 5 divided by 4, which is going to give a remainder. So all the for loop range value I is going to give a remainder. So the prime value remains as true. It never had a chance to execute this block itself. Okay, so all the prime numbers, will never have a chance to execute the block. If at all it executes the block, it breaks there and comes out and declare that as a not a prime number. Okay, so now we have defined this method. Now it is a time to call this method. So I'm going to use this out and then check whether I'm going to call this method is prime. How do you call this method? By just calling the name of the method, and is prime is needing an argument. So I'm going to pass the real value 119. So I'm going to check is prime of 119 is true. So if it is true, I'm going to use the ternary operator here to print it is a prime number. If it returns true, if the function returns false, I'm going to print it is a not a prime number. Okay. I'm sorry. Yeah, now it should work. So this is not a prime number. So I can reuse this method multiple times. As you know, I can just copy this thing and then put it here again to check whether the number 7 is a prime number or not. So that should give us, the result as not prime and prime. Not prime is for 118 and prime is for the number 7. So this function is working for us. The other thing what we can do is, we can make this as a utility basically, so that anyone can call it actually. It's not necessarily that only this person is you are writing this method inside this, instead of this, it's a kind of an utility method that any programmer, your fellow developers wants to use this method, they can also use it. So the best way to do it is, you create a class and say name the class as utilities, or you can say number utils, whatever name you want to keep it. I'll keep it as util, and then say you don't need a static void main there, so just say finish, and all I need to do is this program, I'm going to copy it, or I want to cut it and just put this function inside the inside this class actually. So I moved the isPrime function into utils class. So since I moved this into utility class, all that I need to do is, here it is going to fail because there is no isPrime method in this class. It is going to look only in this class, right? But where is this isPrime method? It is in the utils class, right? So what I need to do here is simply call, say Java that util dot. So you have to call it with util dot isPrime. Instead of calling just isPrime, I'm going to call util dot isPrime, because the isPrime method is not present in this class. If it is present in the same class, you don't need to specify the class name. But if it is in a different class, I need to specify the class name here. Okay. So we can also do one more thing, like we can generate the prime numbers as we saw in the other example. The same thing we can do it. So let's say I want to generate the prime numbers from 1 to 100. All I need to do is for int I is equal to 2, I less than or equal to 100. 2 to 100 in the means, I plus plus. So I want to check whether each of them is a prime number or not. So all that I need to do is, I wanted to print if is prime. So is prime is not available in this class, so I'm going to put if util dot is prime of I, which is going to return true or false here. If it is true, if prime of 2 is true, then I'm going to print the number. Otherwise I'm not printing the number. So I'm going to put is prime of print I here. So now 2 is checked, 2 is printed, 3 is checked, 3 is printed, 4 is checked, 4 is not printed because 4 is not a prime number. So you will get all the prime numbers starting from 2 to 100.